Oh boy. Ooh. Smart. Hello and welcome back to Speed Freak Garage, home of power sports on YouTube. So as you guys have seen so far, we've been making a lot of really fancy, detailed artwork. And when we first installed the mill, we got the vise pretty close just by knocking it around with a mallet and getting it straight. So what we want to do now, in order to start producing car parts, which actually have to be accurate, and I will show you here on this piece of stock, as we were trying to square this stock, there's a little lip here that you can catch with your fingernail. So as far as like artwork, it's not going to be noticeable, but if we're making precision parts, it's going to be a huge problem. So I'm pretty sure the technical term is tramming. We are going to be tramming our vise today, or attempting to. So the first thing you want to do is remove all the accessories from your vise, because if we have to mill the vise to get it square, these hardened steel jaws are going to destroy the end mill. Okay, so we are now ready to measure our vise and see how much of the pretty sure it's tramming. Just give me a break there if that's the wrong word, and see how good it is since the installation. So you'll need a dial indicator and you'll need a decent magnet for your spindle, or a mount for your spindle if you want to go that way. But the spindle magnet works fine for me. So you want to lock it on, make sure it doesn't move. Then we can take, this gauge, which is, of course, trying to be a pain in the butt today, but so we can take this gauge, we're going to come down quite a bit, and then we're going to set it up as dead center as we can. And I usually, what I'll do is I'll go one full revolution. Stop that. I'll go one full revolution and then set it. And it really doesn't matter if you're on zero or not, as long as you're paying attention to where everything is going. So you want to make sure that you get your arm tight so it's not wobbling or moving. Okay. So now, right now at the very left side of the vise, we are at 16 thou. So we're going to turn our speed down, do 15%, and we're going to move over, and just ignore that part that I crashed into. So if we go all the way to the other side, we are now at about 15 thou. So we've got, that was odd. Tighten that some more. Make sure that's centered where I want it. Oh, I see what's going on. I see what's going on. Okay, try that again. Okay, so we're totally different now. We're at 9.5 thou. We're gonna drag back across here. And 10 thou, and then this part here that I screwed up, just ignore that. Okay. So we've got half. Why am I? Oh, I'm maxing out the axis. Huh. Cool. Okay. So we have half a thou that the mill is So I'm gonna exaggerate. So my vise is like this. It's 1/2 thou lower on the right side. If I'm doing that right. No, it's like, yeah? Yeah. It's 1/2 thou off. So for statues, that's fine. For a car part, where the car part could be 17 inches long, that's a huge problem. So what we'll do is we'll take our 3/8 end mill and we'll shave off this. Wait, am I supposed to do this with the vise closed? We're gonna have to do this again. Anyway, it's 1/2 thou off. Vise, I think, is supposed to be closed, actually. But before we close the vise, we're gonna switch over to the other axis. So we're going to go down. Ooh. And probably bring the head down some more. So we're gonna go down to the supposedly precision ground bed of the vise. I mean, it's a cheaper vise, you know, because, yeah, money. But get this nice and tight. Okay, so right now we are at 22 thou. So it's the maximum of that axis. So if we drag out, I can see we're dropping. So we're at 5 inches and we're at 1/2 thou. And at 10 inches out, we're at 1 thou. Now, the widest part I could ever mill is 10 inches. So 1 thou is acceptable. And the reason for that is, in order to fix that, I would actually have to go back and redo my shims down here on the bed of the mill, meaning that the actual head of the mill is still slightly off. It could also be because it's 60 degrees in here right now, whereas when we installed the mill it was 70-ish. I just can't afford to keep the temperature dead at 70, you know. So I'm gonna call this direction good. It's 1 thou off over 10 inches. That's gonna be completely unnoticeable by any standard. We're not, whoa, oh shit. We are not making rocket engines, unfortunately. Now the last measurement, which you cannot do with the vise closed, is going to be the squareness of the vise as far as like the rotational square. This is going to be tough. So we need to know how it handles as far as, so I'm going to go somewhere in there is fine. Okay, so we're at 28 thou, and we're gonna drag across, and it's really not moving, which is better than I had thought. So we're at 28 thou, and as we drag across, the needle is dead steady. We're losing about 1/2 thou. We're about 1/2 thou off ish. So I'm probably gonna have to go ahead and I'm actually not sure how to approach that. Because the parallels when I'm squaring stock sit down here. I think I'm gonna have to, how am I gonna do this? There's a right way and a wrong way to do this. You have to be careful with how you modify the vise, because otherwise you have to start over. I don't believe touching this down here with the mill is smart. Okay, let's check one more measurement here. So it looks like the only thing that's really going to be an issue is this top surface has to be touched up a little bit. It's not near as bad as I had thought it was, which just means there could be something that I'm doing wrong when I'm milling, which is a lot harder to fix. So we're just barely gonna push down on this because we have to go across this channel in the vise. So we're gonna start at about 16.5 thou, and we're gonna have to be careful about this. So 16.5 thou, and the other side of the vise is 16.5. So the vise is square. So that's good. We spent several hours trying to get all this square. It looks like it's just this top surface here on the Mighty Bite that's maybe not in an adequate condition. And we're gonna, although we only use this front piece, we're gonna go ahead and mill the whole top of it and get it right. Now the way to do that is not so straightforward. We're just going to go ahead and do that by hand. I need to get this back somewhere safe. So whenever you store stuff like this, you do not want the measurement instrument to have any pressure on it. So when you store it, you have to kind of be careful about how you store it. In this case, that'll work. So our next step is to go ahead and close this. And if I remember right, Mighty Bite recommends just barely snugging it. Since it's not holding anything, it's could potentially lift a little, and this vise claims it's an anti-lift vise, but I don't believe that for a second because it's Chinese. It does have this keyway back here that's supposed to prevent lifting, but again, it's Chinese. So we're gonna go ahead and close up the vise. Then we're going to change over to our probe, and we need to bump that up or I'm gonna go nuts. Back to 25. Still recording. Yes, okay. I'm wearing safety glasses, by the way, since there's all this mess around here from when we messed up our Rick statue. I just kind of rage quit and walked away after making a $300 mistake. So you want to make sure that your probe is clean, and since the machine has been sitting here, I gotta put this back. It's been a while since I've dealt with this. So you got this brush. I'm gonna brush our spindle out, make sure it's clean, and then I'm gonna grab our probe, double check that it's clean, and oh, hold on, change this to 99 so it doesn't start the spindle on accident. And then we're in G54, so gonna hit our changer. All right, now we're gonna come on back down. And since we're milling this whole thing, we really just need to grab one corner, and then we'll just work our way down 1 thou at a time. Whoop. Okay, we're gonna come up a little bit. Gotta give your probe a chance to do its job. We're gonna make sure this is turned off for now, change it down to 1 thou. It doesn't really do anything for the probing, and then we're gonna probe Z and set work origin. So it comes down, it hits, it comes back up, and then it comes down again slower and gets you a better number. And now we want to get this back up and out of the way. Get this stored back safe. And then I am going to call, I forgot what tool number it was, of course, my face mill. So we're gonna call tool 4. Oh, it's gonna get mad, I think. Remove T99, yes, removed. I like how it asks you to remove the probe before it starts the change, because you could rip the wire out of the probe and that would be a very expensive mistake. Now, shit. So, like I said, I kind of rage quit the last time I was working on this thing, so we're gonna have to do some cleanup real quick. I apologize. So I noticed that this is filthy. They don't give you a way to get in here and clean your tools out. So this is, I mean, these little chips stuck on here could cause all kinds of problems if you're doing precision parts. Now again, when you're doing the statues, it doesn't matter, but we need precision. So I'm gonna go ahead and get her back in there. Okay, now the tool offsets, I actually set them right before I reset all my tool offsets right before I started the Rick statue. And the face mill really doesn't wear that hard. So what we should be able to do is kind of get the face mill down and out of the way. And doing this manually is questionable. Very questionable, actually. But, and let's see, that speed, what is that speed? 50 inch a minute. What does the face mill normally run at? I think it normally runs a little slower. We're gonna run our face mill slow because we want, I think that's still too fast for squaring. Do 10%. Yeah, there we go. Okay, so now what we can do is we can turn our controller back on and we can step. I'm gonna go to X10 and step her all the way to 0. So the first thing we want to do is make a pass at what the probe believes is 0 to see how far off we truly are. And you want to take the minimum, the bare minimum off of this face that you have to in order to get it square, because every bit you take off, you're weakening your jaws. And gonna get our coolant going here. What RPM do we run that thing at? Oh boy, I did not. Hold on, I'm gonna have to load a stock squaring file and look at my RPMs. Nope, that's not the face mill. Come on, where's the face mill code? I did not prepare too well, did I? What? Wait. Oh, there was it. There it was. Go back. There we go. That'll make it a little easier on me. So I'm looking for a tool change to a face mill. I'm getting a little frustrated. Whoop, there it was. We are running the face mill at 3359 RPM, so I'm gonna clear this program. I'm gonna go ahead and kick on my coolant, and I'm gonna set the face mill at 3500 forward. Hey, piece of crap. 100 enter. Forward. Okay, that was weird. Alright, so we are now going to carefully start milling our vise. So it's not making any noise, which is good. That means that our 0 is set right. But you can hear it slowly starting to cut into the vise. Not the vise, the vise jaw, the Mighty Bite jaw set. Okay, So we really didn't cut anything. So we are going to step down very carefully 1 thou. And now we are going to run back. Wait, that would be climb milling? Whatever. Alright, so now we're cutting. But we're just barely cutting. I mean, just barely. And luckily this thing is painted black, so it'll give us a really clear idea of how much more cutting we have to do later. So we're gonna go that way. We need to come down and cut 2 more. Cannot see anything. There you go. You can kind of hear it digging in now. So we do have some jaw misalignment, which needs to be repaired. Okay. And then we're going to come over here. 1 more pass. Oh, quite a lot of misalignment. I like how it draws the path. So you can see I went across, I went down, I went back over, I went across, and I'm going back over. And then this will actually show me if I want to go back to start here, I can just draw it right back to start. Now it's tempting to just open the door and take a look. It's really, you want to be safe, you want to stop it, you want to turn your coolant off, you've got your safety glasses on, blow it off. Okay, so let me show you why our stock is never square. So if you look at the shiny part versus the black part, this is way off. I mean, this is way off. So this was super high, this spot here was high, this spot's low, and this whole side here is low. So we need to go down another thou, and we basically need to keep going down 1 thou at a time until it's all shiny. But again, you want to do the bare minimum. So after we fix this, we should have much better, higher precision parts. So we're going to go ahead and run it 1 thou lower. So with our pendant, we're just going to go to -2 thou. And we're going to fire her back up with the coolant. We're going to go ahead and run across. And I can actually just follow my path here that I did earlier. I don't even have to look in the machine now because I already know my path is right. And I mean, I can't see anything anyway, so hopefully this is the last pass because I really did not want to take too much off. I might have to do this again in the summer when it's 80 degrees in here, because again, I can't afford to keep it at exactly 70 all the time like, you know, aerospace grade machine shops do. Or I think they keep it at like 74. 74? There's an ISO standard that you're supposed to keep your CNC mills at. And let me tell you, I ain't doing that. Nah, no money left. It all is going to the bank. Okay. Just to save us some time, I'm going to go ahead and do it from this side now. Wow, we are still not there. We're so close. So this side here is low. I mean, everything is now shiny except this back corner. So all I can do right now where I am, I can drop down 1 more thou and run another pass and hope that it's all shiny and then we're done and I can go inside and watch anime. It's anime night and I'm out here working because I need the money, like everybody with the 15% inflation bullshit. Okay. Coolant, that would be smart. Oh yeah, we gotta go down 1 thou. We're now at negative 3 thou from where we started. That is quite a bit. That definitely explains why we had so much trouble. So, wait, did we not get a shiny spot? It looks shiny. Yeah, okay, we finally got it right. We're just gonna draw our little pencil drawing over. Whoops, wrong way, up. Then back over. Oh yeah, you can hear it cutting. And I mean, if you were in full mass production, you obviously would be cutting as fast as humanly possible. But this is about precision. We want to make sure we have a good, precise working surface. I might even do one more pass without changing the height. That way, if there's any flex in the tool, which there damn well shouldn't be in a face mill, then we won't lose that. Also because I'm climb milling right now when I shouldn't be. So, I don't know, let me check the surface finish before I go and waste another 5 minutes milling. I'm gonna run the mill off, stop, coolant off, and safety glasses. I didn't really, and I need to get all that coolant out of those holes that aren't plugged. Woo! Sorry about the air compressor. I just bought one from Buckeye. Oh yeah, that's fucking smooth. Smooth. Okay. I'm gonna call that good. I mean, it's square now, except for this part I destroyed, but that's my own fault. But so we now have a trammed vice jaw. If that's the right term, I don't know. We're gonna put this tool away. I really need to get in there and clean the rest of those tools off. So anyway, that is like a basic first day of kindergarten method for tramming or squaring your vise or whatever technical term you want to use. So we checked the vise in X, Y, we checked the vise in rotation on X and rotation on Y, and then we found that there was a discrepancy on the X rotation, and so we fixed it with the face mill. If there had been a discrepancy with the rotation like this, the Z rotation, we would have loosened these nuts, tapped the vise, tightened the nuts, checked, repeat, and you do it again, and you do it again. And you do it again, and you do it again, and you do it again until you get zero run out. I think that's the word, zero run out. Because to actually get a mill down in here and to mill the face of your jaw, you can't do that while the vise is loaded. Because when you're working, your vise is loaded. So, again, this is the beginner, kindergarten, first day, 101, like, we need to make parts, and the parts need to be good, so we made our vice jaws good by force. So anyway, I hope this helped. Thank you guys for watching, and we will see you next time.